Right. So in the previous lab, we were seeing the default non-broadcast network type. When I go to router 1 and check router 1 and show you the neighbor, show IP OSPF neighbor, we need to configure neighbors manually. Yeah, we need to configure neighbors manually. We have configured it. So it is trying to attempt now to establish neighbor. Meanwhile, I would like to show you show IP OSPF interface serial /0. Here you can see the timers are not 10 and 40, it is 30 and 120. And then if you see the network type, it is non-broadcast. But remember, we did not configure this network type as non-broadcast. When I enable OSPF on an interface which is running frame relay, let me also show you that. Show interface serial /0. You see the encapsulation type is frame relay. So when our encapsulation type is frame relay, the OSPF NBMA type is going to be non-broadcast. The OSPF network type is going to be non-broadcast. In non-broadcast, we have to configure the neighbor manually. We have already configured neighbor manually in the previous lab. I would like to show you that. Show run section router OSPF. Here you see, wait, it's coming. Okay, here you see that 3 neighbors are configured. As a result, when I say show IP OSPF neighbor, I can see those 3 neighbors and their router ID. We did not configure their router ID as a neighbor address. You are seeing here right in front of you. You don't see 2222, 3333 or 4444. We gave the serial interface address of the remote devices, which is reachable via frame relay, and OSPF was capable enough to send a unicast hello packet to these address 10.0.0.2, 3 and 4, negotiate OSPF, and OSPF has come back forming neighbor. When OSPF comes, it shows the neighbor address as the neighbor's router ID. Next. We have also set priority 0 for router 2, router 3 and router 4 because this is non-broadcast. Non-broadcast network type is suitable for full mesh because of the DR-BDR election. Because we are not ready to have DR-BDR. Because we are not ready to have full mesh. We need to cancel that election process. So what we do is we set priority 0 so that there won't be DR-BDR election. Yeah. But we don't need to do all these things. You can go for the next method, next mode. That's the best option. We can move on with the next mode. Yeah, we are going to do that now. But before that, I would like to remove this static neighbor configuration, which is not necessary for the next mode. Another thing is, you see all these 4 routers are in same subnet: 10.0.0.1, 10.0.0.2, 10.0.0.3 and 10.0.0.4. Okay, so these are the points that we learned under NBMA network type non-broadcast. Are you comfortable with NBMA network type non-broadcast, or do you have any question?
Yes, sir.
That's good to know. Now let us go enable another network type. As I said, I have to remove the static neighbor configuration that I have put. So I'll use Notepad. I'll use WordPad better. Okay, there is no WordPad in this newer version. Notepad only available. And this Notepad is not that friendly like before. So you all wonder. Okay. All right. I'm asking to paste. Okay. I'll remove this. Similarly, I have also configured neighbors on the other routers 2, 3 and 4. I wish to remove them. I don't know why this abnormal behavior of this new operating system after upgrading. Too abnormal, not friendly. Show run section router OSPF. Yeah, this is the only neighbor we have, neighbor 10.0.0.1. So I'm going to cancel 10.0.0.1. I'll put this command on every router, all spokes router. All right. So we will not have any neighbor now. The neighbors all will go down now. I'll clear IP OSPF process. Okay, this neighbor should not come up again. Again, I would like to show you once again, show IP OSPF interface serial 4/0. It is in non-broadcast network type. Now, when I change the mode to point to multi-point,
Yes.
what do you expect? First thing, the neighbor should come dynamically up. Second thing, there should not be any DR/BDR election. Yeah, so those things I have to verify. I remember I also set some priority on the interfaces, you see. I'm going to remove that.
Yes, sir.
No IP OSPF priority. So it will go back to default. Let me show you. It should go back to 1. See, the priority has gone back to 1. And the neighbor state is still waiting. It will not come up because there is no multicast supported in non-broadcast. I also want to change the priority here. Show run interface serial 4/0. Yeah, I do have the priority configured here. So here also it will go back default to 1. We made 0, but it will go back to 1. Let us check that. Show IP OSPF interface serial 4/0. You can see here the priority is 1. Now it's not 0. Next, router 3. Even in router 3, I will remove the priority. Alright, done. We have removed the priorities. Best, when you do the lab, remove OSPF and put OSPF back. That is better. Instead of doing this alteration work, you would have enabled OSPF by cancelling it. That would have solved the problem the easy way. Okay, now let us move on to the second mode, point to multipoint. DR/BDR should come up. Is it true or not? No.
No, sir.
No DR, no BDR. Correct. I don't know how it is going to loading to full. Show IP OSPF neighbor. No, you need to clear. Clear IP OSPF process. Also on router 4. I'm just checking whether any configuration is still there. Okay, no configurations. Now, moving on to point to multipoint. See, the command is under the interface. The command to change the NBMA mode is under the interface. Interface serial 4/0. Because on the interface only we have frame relay, right? So you may have one interface with frame relay, another interface with normal Ethernet. Yeah, this NBMA is applicable where? Only on frame relay interface. So it is per interface. It is not global, it is per interface. You understood?
Yes.
Okay. IP OSPF network type point to multipoint. And this is the same command we are going to repeat, so I'll use a notepad.
Okay, sir.
Interface serial 4/0 IP OSPF network type point to multipoint. And then what I'll do, I'll shut down once and no shutdown. Just refreshing, no, it is okay. I'm refreshing the interface. Any question?
No, sir.
So this is what I'm going to paste it on the other spokes. Now you will see neighbors dynamically discovered. Neighbors are dynamically discovered, you see. Loading to full.
Yes, sir.
Show IP OSPF neighbor. And there will not be any DR BDR election, you see. State is full with everyone. Even with 2 to 2, it will become full in few minutes, few seconds. It is in init state now. It will become 2A, start exchange, loading to full sooner. Let me go to router 2 and see the status there. Show IP OSPF neighbor. Here it is in start state. See, when will it get stuck in start state? If there is MTU issue, maximum transmission issue, you will get this. Let's verify. Show run interface serial 4/0 encapsulation frame relay network type okay. Show IP OSPF neighbor. Why it's still in? We did not set any MTO. Show IP OSPF neighbor. Here now it is in start state. From init it has moved to start state. Show run interface serial 4/0. I'll do one thing on router 2. I would like to shut down. Let me check the frame relay map. I don't have, that is the problem. I don't have a frame relay map to reach 10.0.0.1.
Okay.
But it's supposed to come dynamically. Neighbor down, too many retries. Okay. This is not normal. I would like to shut down once and see. Interface serial 4/0. I'll shut down once. I can write statically frame relay map. That's not a problem, but it should not happen like this. There is a protocol called inverse ARP that will help to create a frame relay map.
Okay, sir.
Inverse ARP is only for frame relay. It's not a normal ARP. I said shut and unshut. I'm waiting for some positive result. Even now I don't see. Okay, I'm going to write manually the frame relay map. Interface serial 4/0 frame relay map IP. Now the address is 10001. Has to go to the DLCI number 201 and then broadcast. Now you will see OSPF forming neighbor. See, we did not write this 10.0. See, it has come now. We did not write this one on router 3 and router 4. 10.001 we did not write. Show frame relay. See, 10.001 it is dynamically learned. We did not say the things when it happened in router 3. Why it didn't happen in router 2 is surprising me. Okay, but we know how to fix it. We can write statically if it is not coming. We have written statically. Okay. We saw now the neighbors are dynamically discovered and there is no DRP-DR election. Show frame relay, show IP-OSPF neighbor. We can see router 4 is also in extart state. Why router 4? Why? Show frame relay map. Okay, wherever I gave this 10.002 and 10.003 manually, there is a problem. In router 3 I did not give this one and it has dynamically discovered the one which it's supposed to. So what I'll do is better, I'll write another line. Or I have to remove those two static. I'll write another one. Frame relay map IP. If you want to go to 10.001, DLCI number is 401, broadcast. This will fix the problem and the neighbor will come up. I'm expecting neighbor to come up at any moment. It has come. Neighbor down. Okay. Interface serial 4/0. Okay, it has come up. Okay, the neighbor has come up. Now let us check whether there is a DRPDR. Show IP-OSPF neighbor. You see there is no DRPDR full state. Also check the same on router 1. You should see all with full state. Neighbors are dynamic list. What about the timer? Show IP-OSPF serial 4/0. Show IP-OSPF interface. Hold on. Here it is. The state is what? Point-to-multipoint. And the timer is 30 and 120.
Yes, sir.
Adjacent with this neighbor, this, these are all dynamically learned neighbors. Okay. Network type is point-to-multipoint. Okay. So what is next? Next one is point-to-multipoint non-broadcast. See, it's same point-to-multipoint only, but we are going to additionally add one more keyword, non-broadcast. First, let me shut down all the ports and then I will explain you. I've shut down. Better use the notepad. I'm shutting down the interfaces. Okay, so I've shut down the interfaces on all the routers. We are going to change the mode. For that,
Okay, sir.
also I'm going to use a notepad. One router I'll do manually, and then another router I'll do using notepad. You see, this is the command. Already we gave this command IP OSPF network type point to point. Now I am going to say non-broadcast to it.
Okay.
Okay, just we are going to add non-broadcast to it. And I'm going to unshut. Right, now I pasted. I also say unshut. Also I pasted here. Come on, don't do this. Pasted. 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 Okay. So what do you expect when it is point to multipoint on broadcast? We expect no automatic neighbor discovery. OSPF will not come up
We need to queue the neighbors manually.
manually. And another thing which we can expect is no DRBDR for this. See, that's the difference between non-broadcast and this point-to-point non-broadcast. In non-broadcast, what we saw is there will be DRBDR.
Yeah, PD.
There will be DRBDR. Neighbors are neighbors are manually configured. Here, neighbors are manually configured, but there won't be DRBDR. Let us verify that. Neighbors need to be manually configured. So I use the notepad. This is what I put on router 2, 3 and 4. Router 2, 3 and 4. Router 1 is the neighbor. Accidentally I pasted the same on router 1, but I'm going to remove it. See, the neighbors are up already. Well, when you do on one side, it will come up automatically. Negotiation happens. Now, there won't be DRBDR. That's what we want to check. Show IP OSPF neighbor. You see, it's full. No DRBDR.
Yes, sir. Neighbors are manually configured, but no DRPDR election.
Okay. So now other things are easy. If you go here and say interface serial 4/0 IP OSPF network type broadcast, even though it is a non-broadcast environment, it will give you results like broadcast, meaning 10-second timer, DRPDR, dynamic discovery. Whatever you used to see in a broadcast environment, You will experience the same here, though it is not truly a broadcast environment. Also, we have another option called point-to-point, you see. Even though it is a non-broadcast environment, you will get a point-to-point experience where there is no DR, BDR, and you can have multiple subnet, meaning R2, R3, and R4 can be in different network like 10, 20, 10 network, 20 network, and 30 network. Right? We'll see this in our next class.